our bell work today. It's a little bit hidden, perhaps, but what we've got here is a system of equations, and you might not look that way to you. I can share the poll real quick. We had kind of a scattering of answers, no real consensus on what the correct answer is. A and D both had pretty strong support. So let's kind of see which one is the correct answer. Now, you can think through this problem in a few different ways. The way I'm about to show you is not the only way you have to do this. In fact, whenever I look at this problem, just my own thought process is I try and think of all the numbers that add up to 11. And of those two, of all the sets of numbers that add up to 11, I try and think, now which ones, when I take this difference between them, do I get 5? And maybe that's what you did in your head. Now, if we made that explicit with using equations, then that's essentially what we're doing in our heads. So let's kind of see what's going on. The sum of the real numbers x and y is 11. This is an equation written out in English. So if I think about it this way, it's x plus y equals 11. That's what it's telling me. Their difference is 5. So that tells me x minus y is 5. This is a system of equations. We have two equations for two unknown variables. We can solve, what we can do is substitution. If I wanted, I could rearrange this formula right here and find out what x equals and substitute it in. But I want to approach this a different way to remind you of another way you could solve a system of equations, which is using elimination. So I want to take this, pretend like this entire equation is basically just an expression that I can add to another expression. What I've got is I'm going to add these two together. And the reason I add this is look what happens. X plus x is 2x. But y plus negative y, those cancel out, so I don't have anything there. And then 11 plus 5 is 16. So by using elimination, I can actually get an equation that I can solve. So now I can just divide by 2. X equals 8. This is not my final answer, but now we're on the path toward an answer. So I'm going to take this 8, and it doesn't matter which one of these equations I plug it into. I'll just, just for fun, I'll plug it into this one. X minus y equals 5. So I know that x equals 8. So I'm going to substitute that in. And now I can rearrange. If I add y to both sides, you get 8 equals y plus 5. If I subtract 5 from both sides, I get y equals 3. So I'm putting boxes around these, but these aren't my final answer. My final answer is going to be x times y. So now that I know what x and y are, and I can double check this, make sure that 8 plus 3 equals 11, it does. 8 minus 3 equals 5, it does. So we're good. Now I can do 8 times 3, because that's x times y, and that'll give me my answer of 24. The answer is J. Okay. Again, not the only way you had to think through this and solve it. Some people probably didn't put nearly this much work into it, but you're able to kind of see what was going on and do a lot of this in their head. If your brain works that way, by all means, go for it. All right, if you like to write out your work, you can do this or do it a different way. All right, I've said enough on this. Let me clear this and we'll move forward. Today we are going to be looking at density, and I already have assurances from my first period class that this is not the first time you've ever heard of density. You've seen it in previous classes. So this is going to be kind of putting it in the context of some geometry problems. And some of them you're going to have to do some extra calculations for, some of them you won't. So as a reminder of what density is, it's the measure of mass per unit volume. So if we look at iron, it has a density of 7.86 grams per cubic centimeter. So if I gave you 1 cubic centimeter of iron, it would weigh 7.86 grams. If I gave you 10 cubic centimeters of it, it would weigh 78.6, which is just 7.86 times 10. So there's a direct relationship between the density and the volume and the mass. In fact, we can see that right here given in this formula. It's going to be on every page. If I give you a problem like this on your test, which you should expect one of them, then I will give you the formula for that. So you don't have to have this memorized, but you do need to understand what's going on. And as far as density goes, this determines a lot of the properties of matter. So if your substance is dense, then, well, let me put it this way. When you have less dense things and more dense things, the less dense will float on top of the more dense. And this is stuff you're already familiar with. So you can take styrofoam and put it in water, and the styrofoam floats because it's less dense. Pretty straightforward concept. And this is true no matter whether you're talking about liquids or gases. And so when you're thinking about our atmosphere, you have a helium balloon. Helium is less dense than our atmosphere, so it wants to float. It's trying to get up to kind of float on that sea of atmosphere. Okay. And, there's lots of properties related to density. One thing I'll point out real quick is that if you're in a science class, you might refer to density with this letter, which is the Greek letter rho. But we are not going to worry about that. We're just going to use D for density. But I just so you maybe can have a reminder of that if you've seen that before. So we're going to go through a problem like this. If you have a rectangular block of copper metal and it weighs 1,896 grams, and you have the dimensions on that block, what is the density of copper? So because density is determined by mass per unit volume, if I can figure out the mass and the volume, then I will be able to figure out the density. The mass is already given, so I'm going to go ahead and substitute that in. That's 1,896. The volume is what we need to solve for now. And I'm going to go ahead and put grams right here. So let's go ahead and figure out. This is a block. Another way of thinking about a block is that it's just a rectangular prism. Draw that just a little bit nicer. There we go. So it says my dimensions are 8.4 by 5.5 by 4.6. So you have these dimensions that are perpendicular to each other. Okay, you know how to find the volume of a rectangular prism. I'm just going to put this right here, volume equals, and I want you guys to calculate this and tell me what the volume of this prism is. All right, this is the answer that I was able to calculate. Hopefully it's the same answer that everyone was able to calculate for the volume. In case you got lost somewhere in the way, remember we want to find the area of the base. The volume of a prism is the area of the base times the height. This is a rectangular base, so if I can get the volume, or sorry, the area of that rectangle right there, then I can find the volume. So the area of the base is going to be the base of our rectangle by times the height of our triangle, not triangle, rectangle. So it's 8.4 times 5.5. And once we have that, what is that number? 8.4 times 5.5 is 46.2. And then I can multiply that by the height of our prism, which is this value right here. Remember, that's what's perpendicular to the base. So it's going to be 4.6. And that's when you multiply out, you get your 212.52. Now, I wouldn't recommend rounding to the tenths right here. If you have extra precision, go ahead and include it, because this is not our final answer yet. So 212.52 cubic centimeters. And now we can plug that in to our calculator. So 1,896 divided by 212.52, we get 8.922 when we round it off. Now this is important. The unit of density is mass per unit volume. So it's going to be gram per cubic centimeters. This is not an absolute mass. This is saying this is basically a rate. For every cubic centimeter that you have of this substance, copper, you will get 8.922 grams added to your total weight. And if you check this, that is the actual density of copper. So there's our answer. Any questions on this process? All right, I hope everyone's clear with that. Like I said, this shouldn't be the first time you've heard of density. So this is really more of a reminder than it is anything else. Okay, here we go. A cylinder filled with ethyl alcohol has a radius of 2.5 centimeters and a height of 12 centimeters. If ethyl alcohol has a density of 0.789 grams per centimeters cubed, what is the weight in grams of the ethyl alcohol in the cylinder? All right, there's a couple things I'm going to do to get started on this. I'm going to go ahead and write down my density formula, which is density equals mass divided by volume. And I'm going to go ahead and write out my volume formula. Because this is a cylinder, it's going to be the area of the base times the height. What is the area of the base formula for a cylinder?
Squared.
Okay, there it is. So I was looking generically, it's pi r squared, but yeah, you filled it in with the number here. So I'm going to leave this again, and you guys can just record maybe right here what the volume of this cylinder is going to be. All right, just to make sure everyone is good, no one is lost behind, I'm just going to show you what you should have done here. We start with the area of the base, which is pi times 2.5, which is the radius squared. In fact, it tells us right here, radius of 2.5. Once we get that, which is about 19.63. Now, in my calculator, what I did was I kept the entire precision. I just stored that number in my calculator and used it for the next calculation. But if you rounded to like 19.63 or 0.635, then you would have gotten a little bit you would have rounded a little differently than me. But now we take that, and that's that 19.635 times the height of the cylinder, which is given right here. That's just 12. And that's where you get your final answer, which we see down here. Again, just be in that ballpark. You're going to be close enough. If you're within a tenth of the final answer, then you're good to go. And this, you can see, even with rounding differences, we're only 1/100th apart, basically. So now I can substitute some things in. I just solved for the volume, so I'm going to go ahead and write that in. That's 235.619. I'll put my answer, but you can put your own answer if you got it a little different. That's the volume, and maybe I can put this is centimeters cubed. Now, the density has a unit of grams per cubic centimeter. So this is going to be, the density goes right here, 0.789 grams per cubic centimeter. And what we don't know is the weight. That's what it's asking for. So I'm going to put the mass right here. So weight, mass, for our purposes, are the same thing. Okay, so to solve this, it's just algebra. All right, but I do want to go a little bit more into it because this is the mass. Okay, sorry, wasn't showing up. That is the mass. So I want to multiply both sides by 235.619. And I'll multiply this side by 235.619. But look at what happens here because we have these really weird units. So I'm going to get 0.789 grams per cubic centimeter times 235.619 cubic centimeters. The straight up calculation on the calculator is straightforward. I'm just going to do that. 0.789 times 235.619. And I get 185.9. But see what happens with our units here. This is centimeters cubed, which is the same as centimeter cubed over 1. So this centimeter cubed in the numerator and centimeter cubed in the denominator basically cancel each other out, and I'm left with just grams. So that's how this unit works out so that we can find the mass based on this calculation. And this is our actual answer right here, not that one. Okay, questions on this one? Okay, we have one more that's going to be a little bit more of a challenge. Right here. So I'm just going to give you guys, it's 11:07 right now. I'm going to give you about 4 or 5 minutes just to look at this, see if you can come up with the final answer yourself. And I'll just do this. If you can come up with the density of gold, feel free to write it on the screen or chat it to me. But I'm going to give you about 4 or 5 minutes to work on this entirely on your own. I wanted to go through this problem. We did end up with the correct answer a couple of times, and I'm sure even more people got it right. Maybe they just didn't communicate with me. The tricky thing, I don't know, tricky, but the thing about this one is that we know the weight, we can find the volume, we need to solve for the density. So if I'm kind of thinking through this from the beginning, then I will go ahead and substitute in the mass, which is 1,389.6 grams. The volume I will leave blank for now, but I will be able to solve for the volume of that. So let's kind of jump over now and look at this. Because it's a pyramid, it tells me it's a pyramid. I'm going to do area of the base times the height divided by 3. And because it is a square pyramid, the area of the base is just going to be a rectangle. So base times height. And it tells me those numbers. So I'm just going to kind of go through this a little bit quickly. The base is 6 centimeters by 6 centimeters. So there it is. 6 times 6 gives me 36 square centimeters. That can be plugged into this formula up here. So it's going to be 36 times the height of the pyramid is 6 divided by 3. This, when I plug it into the calculator, gives me 72 cubic centimeters. All right, I'm not taking my time to calculate that out on the calculator. You might have already done that if you knew what you're doing. But otherwise, you can see the work right there. You can just do 36 times 6 divided by 3 on your calculator to make sure you get the same thing. Now I will take the volume and plug it in. 72 cubic centimeters. And at this point, we've done all the hard prep work, and we can just plug this in. 1,389 points divided by 72 is indeed 19.3. And because the grams and the centimeters cubed don't cancel each other out, we end up with the unit grams per centimeters cubed. And if you look that up, that is actually the density of gold. And notice copper, the density was 9.22. I think that's what we came up with. The density of that liquid we were talking about earlier was less than 1. This is 19.3. This is a quite dense material. So notice this rather small pyramid. If you think about the actual size of it, it's not that big, but it weighs it's about almost 1.5 kilograms. So we're looking at about 3.5 pounds, something in that range. So it is, quite heavy. Not the densest element that there is, but it's quite dense. Okay. So I'm going to go ahead and clear this. That's the whole process. If any of this didn't make sense, of course, you can always stop and ask questions on this. Let me clear it. What I'm going to do now is I'm going to get the homework pulled up. Oh, sorry. All right, let me get a new thing shared. That's not working for me. Sorry. Here it is. There it is. All right. So this worksheet right here this is actually a little bit simpler than the stuff that we were just going through. And so on Monday, I'll give you some more practice where you actually have to find the volume. There is a problem right here where you need to look at this, find the volume of this block, and then you can kind of go through these steps. I'll just do one of them with you real quick. I'm going to look at problem number 2. This example is already here, but with problem number 2, we have a block of wood that has a density and a volume that are given. What is the mass? So I'm going to start off every single time with this formula. Density equals mass divided by volume. And you can see that's on the page, so you don't have to have it memorized. And I want to figure out what I already know. It says I have a density of this, so my density is 0.6 grams per centimeter cubed. The volume is 1.2 centimeters cubed. So if I plug these in, if I plug the D in right there and the V in right there, then I can get 0.6 equals mass, which is unknown, divided by 1.2. Okay, so that's kind of what we're doing in the third column. And the very last one is after you've done the algebra from here, you can actually solve. So you'll get your answer, and make sure you put it in the correct units. If it's mass, we're going to have grams. If it's volume, we're going to have centimeters cubed. At the bottom part of this, you can take a picture of that if you want to have a screenshot of what you're doing. You do have the example up above as well. All right, actually, it's not letting me erase. Okay, it does this sometimes. We won't worry about it because I'm only going to be here for a little bit longer. With this one, you have the mass and the volume given. You are finding the density. Pretty straightforward. You just do mass divided by volume. You can get your density right here. And what you're trying to figure out is what is the substance that we're looking at. If we end up with a density of 13.5, it's mercury. How do we know that? This is where you're going to have to look at the top right, and you have this table. Notice it gives you densities of different substances. So because we got 13.5 as an answer, that has to be mercury. We already found 19.3 is the density of gold, and anyways, all the way down to air. So I want you to go through, solve for the density of these different substances, and just write what they are. You can turn in this worksheet with your answers. If you want to take a picture of it, you might be able to upload pictures. Otherwise, just type in what you can. But there it is. If you have any questions, please let me know. This or anything that we've done in the past. If you're good to go, have a wonderful day, and I will see you next week. Have a great weekend.